in this problem, we want to take the integral of this function. This looks like a complex function e to the negative x times log of another function over another function. So it's a little bit complex looking, and usually whenever we have a composition function, which is function of function, like f of g of x, in this case log of e to the negative x plus 1, usually U-substitution would be a good starting point. Again, it's not always true, but sometimes it's really good starting point because it helps us to have a simpler integrals, so which we know already the integral. So let's begin with using U-substitution and call e to the power of negative x plus 1 to be our u. So this is u. Let's evaluate the du. The du would be the derivative of this, which is negative e to the negative x. So basically the derivative of that is e to the negative x times the derivative of the top, which is negative 1. It's a chain rule. And at the end, we have a dx. Because we want to do the substitution, we want to substitute dx. So we need to isolate for dx. So what I do, I divide both sides here by e to the negative x, negative e to the negative x. So I just divide both sides by negative e to the negative x here and here. And what I get is dx is equal to du over negative e negative e to the negative x. So let's just rewrite this integral by applying this substitution. So what I get is integral of e to the negative x log of u over, again, I have the same term e to the negative x plus 1, so I just simply write u here as well, multiplied by dx, which we already know what it is. It is du over negative e to the negative x. The good thing is this e to the negative x and this e to the negative x get cancelled. So now we have a very simpler integral. If I take out this negative sign, I would get negative integral of log of u over u du. It's definitely better, kind of better looking than this one, but still we need to think about how to solve this integral. To solve this integral, again, what we see is log of something, log of u over u, or I can just write it as log of u times 1 over u. And we should know that 1 over u is the derivative of log of u. And because I see the derivative of a function and a function multiplied by each other, I can think of U-substitution again. Just because I already used the letter u, the parameter u, I would come up with another parameter. Let's use t. So let's just say that the log of u, let's call this to be the t. So from here, what is dt? dt would be derivative of this, which is 1 over u times du. And again, we want to replace du as well. We want to substitute du. So here I simply solve for du. To solve for du, I multiply both sides of this equation by u. Multiplying this here cancels this 1 over u. So I'm just left with du, and here I am just left with u. Now I can rewrite this integral in terms of t. So I have a negative sign at the front. I would just write it again. Integral of log u, which I'm replacing that with t, over u times du. And instead of du, I have u t, which can be written as, simply I can cancel these two, and I can write that as negative integral of t dt. Very simple integral, which we already know that we need to apply power rule here. And it would be negative, the integral of t is t squared over 2. It's indefinite integral, we need a plus c at the end. So But still make sure that because it's an indefinite integral, we cannot leave these as a final answer. We need to have it, we need to have the final answer in terms of our original variable, which was x. So we need to kind of undo all of our substitution. So first substitution was t is equal to log of u. So basically the final answer, let me just call this I, the integral. The integral is equal to negative log of, again, this is what I'm just rewriting this thing. Instead of t squared, I have log of u squared. I'm just replacing t with log of u. Log of u squared over 2 plus c. But still, I need to get to x, our original variable. So I need to know what u is. U was introduced here, e to the negative x plus 1. So I do that as well. U is equal to e to the negative x plus 1. So instead of writing this, I can rewrite that by substituting u with this. So I would get the integral, the original integral is equal to negative log of e to the negative x plus 1, all of that to the power of 2 over 2 plus c. Make it a little bit better looking, I would just write it as negative half log of, because it's log entirely squared, I put the 2 here, it's less confusing, log squared of e to the negative x plus 1 at the end plus c. This would be the final integral or antiderivative of the function that we had. We basically, what we did two u substitutions, one for this part and at the end for the log of that. Or if you wanted, if you could see that, you could do it with one shot and just use this to be the u, and you could do that in just one u substitution. But sometimes it's not easy to see that kind of more complex substitution, so we can do it in multiple steps. It doesn't matter, at the end this would be the final answer.